Hi everyone, welcome back to our introduction to Go programming series. In this video I'm going to take you through the concept of structures, which are basically structs in Go, and we'll go on to talk about our type declarations and everything that comes under that. So if I look at what we have today, we'll talk about structs and constants, pointers, and then functions and methods. Okay. So structs are like I mentioned in the previous video, it's a data type. So it's a type that holds data, okay, that aggregates different kinds of data values, okay, of different types. All right. So when you talk about different types, you mean like strings, integers, floats, and even structs themselves. Okay. So struct sort of aggregates this data to create a type that makes sense in some way. Okay. So a classic example that I used for this for the structs the explanation is let's say that we have a data type that we want to represent the statistics of the current COVID-19 status in Nigeria. Okay, so we might do something like this. So we define a struct type, and we'll name that COVID-19 stats, and it's going to be composed of the country. That's the name of the country, the number of cases so far, and of course safety measures, which in turn is also a struct in itself. Okay, so this is a bit complex. Don't feel intimidated yet, because if you understand the concepts of arrays and maps, they are basically of the same thing. All right, but don't worry. As we walk through it, you will see some of the differences and why you would use a struct type instead of a map. Okay. Okay, let's dive straight into the code. All right, so I've moved okay, by the way, this is go by examples, I think, not example. Okay, so actually let me just quickly check this and make sure that it's correct. Let's see, is that correct? Go by example. I think it's example, not examples. So yeah, go by example. So yeah, that was correct. Okay, so we've defined these types. Okay, and as you can see, I'm getting a warning. This is a warning. This is a warning message because of the yellow squiggly line. Okay, so when you see a yellow squiggly line, then it's a warning. It means your code can still compile, but it's not. There is something that they go like there's just something that is warning you about. It's not enough to cause an error. Okay, so for this case, it just basically means that we have an exported type that does not have a comment. When we talk about packages, we talk about exporting and importing, but for now, just think of exports as the concept of exporting data or functions to the other packages that exist in your program. Okay, so whenever we use a capital letter to define any type, let's say a struct type, a function type, any data type, whenever we use a capital letter as the name, then automatically that function or that type is exported. So because of the capital letter, it's expecting us to use a small letter to add comments. So just go ahead and add that comment. So that goes away. Say represents the COVID-19 status. Okay, so see, it goes away, and down here you can have the same thing, safety measures, which presents the necessary precaution to reduce the spread of COVID-19. Yeah, that goes away too. So let's start by defining a variable that would be of struct type. So there are many ways that we can achieve that. So we can use the new keyword, the new function that is inbuilt into the Go programming language, just like the make and the append. So we can do something like a Nigeria plus the new, let's say new COVID-19 starts. Okay, so this goes ahead and creates that and returns the pointer. All right, so because we've not talked about pointers yet, I won't go deeper into that. Until we talk about pointers, then this will make sense to you. All right, so yeah, so there we go. We have a variable that is of type struct. Okay, so we don't want to use pointers for now, so I'm just going to change this to a literal. Okay, so yeah, Nigeria is a struct type. Okay, so as you can see, my IntelliSense is telling me showing me the definition of the struct type. So if we go ahead and print this to the console, oops, so by default all of the fields are going to be instantiated with the zero value of every type. So the zero value of a country is string. So as you can see, there's an empty string here. We're just not seeing it. So for ints, it's 0, as well as seeing 0, and for struct, it's nil. Okay, but nil is represented with the open and closing curly brace. Okay, so everything is initialized to 0 here. Okay. All right. So the next thing would be to define some values. So to do that, we can use this to define the name of the country. So call it Nigeria, and then we'll have number of cases, and I think we've 81 now. And then safety measures, can just initialize this to an empty struct for now. So something is not right. Yeah, I missed the comma. So the trailing comma is very, very important. You must always end it with a trailing comma. So I'm going to go ahead and save that and run, and as you can see, it's showing up nicely. Okay, so so we can also like I've mentioned, we can create a new struct using the new function, but it returns a pointer. And so because we've not really talked about pointers, I will not treat this now. Pointers will be the next thing that I talk about. Okay, so we can access the data inside our struct using what we call the dot notation. Okay, so let's say we want to print the country. We'll put the dots, and as you can see, once I type the dots, I get suggestion from my IDE, and I can now say I want to print out the country. I can type out country, and if we run this code, you should see that gets printed out. So the same thing, let's say we want to print out the safety, same thing, and say we want to print out the number of cases, and it still works the same. Okay, yeah, so we can actually write a very simple program that just combine what we've learned so far with control flow. So we can say if let's say Nigeria dot country is equals to let's use number of cases. So if the number of cases is greater than 50, you can go ahead and say fmt dot println shut down the whole country. Yeah, so yeah, it's a very simple program. Else, you can say something else. Maybe you say, yeah, so actually anything you want to happen here, just actually, write that there. So yeah, that's that. So yeah, I think that's just basically what structs are about. Yeah. Okay. So yeah, we can also use the dot notation to do our to assign new values. So let's say, for example, we don't want to, you know, declare things like this, so we can actually have a new, let's say we create a very empty data struct, so we can populate the data using a dot notation. Just use the assignment operator, so assign the country name and everything should work as planned. So maybe say Nigeria dot number of cases, let's say equals to 49, and check that and see prints nothing. For increase that to 81 and still have yeah, shut down the whole country. So the dot notation also works as expected. All right, so okay, so that's that. So these are the concepts of methods, which I will talk about once we start talking about functions. So but for now, that's all you need to know about structs, and we'll see more of this as this course goes on. Okay, so the next thing I'm going to talk about is pointers. Okay, so what are pointers? I mentioned earlier that pointers are basically an address to a location on your computer memory. Okay, so whenever I say that something gives you a pointer of something, just know that it means that it returns an address where something is located. Okay, so by default, let's say for example that we want to print let's say we want to print this to the console. All right, let's say we have we define a struct value and we want to print it out to the console. If we go ahead and pass this to this function, right, it works well. Okay, but what happens here is that we are copying the value of Nigeria into this method for printing, purposes. Okay, let me demonstrate this thing using another function. So let me use what we call a setup function. Okay, don't worry, we'll talk about functions before we're done with this particular lesson, so don't worry too much. So let's use a setup function that just sets let's say it sets the country. So set country, and we know that the just going to pass a string here. Okay, so it should give us okay, so country, let's make this type COVID-19 starts, and we're gonna value the value that we want to set to the country. So what we can do, we can go ahead and say country dot country equals to value. Okay, so let's reduce the confusion here by changing. Let me change what I'm using here. So just call it country. Or let's just use a count. All right. Which is even worse. So there are the two most difficult things to do in computer science. The first one is catch invalidation, then followed by naming things. So naming things is extremely hard. It's a skill that must be learned. They probably never learn to the end of your career. So let me just use CNT. Okay, I'm going to save that, and yeah, so let's come here and print the first value of our country. All right, and also try to set it by calling set country, and we pass the country that we want to set a new country value to, and then we'll pass the value and just say Ghana. Okay, so go ahead and print out the solution. The new value, which we expect that the new value should be Ghana, right? Let's run that and see. Oops, what just happened? It's still Nigeria, even though we set it down here to become Ghana, but we're still getting the same results. Okay, now this is because by default this Nigeria variable, or value, is passed into our function as a value. It's not passed by reference, it's passed by value, which basically means that the value is going to be copied. Like, we're going to copy the exact value into this function. So basically a brand new Nigeria will be created by the Go compiler and then passed into the set country. All right, and whatever that is being called on this is going to print something else. It's going to whenever that is being called on this, will set a different country and not the one that was passed into the function. Okay, so again, if you're confused, don't worry, I'll talk about functions next, and hopefully it will be clear to you. Okay, so now let's try and print out this country value here and see if we're going to get a different information. So remember, this is a of type COVID stats, so we expect that there is a country value there. So if we save this and run this code, as you can see, it prints out Ghana here. So this is actually where this is happening. All right, which means it was set, but then the main variable that we try to change the value actually does not do that. Okay, so how do we solve this? So now this is where the concept of pointers come into play. All right, so a pointer is a location of where this variable is saved in a computer memory. Okay, so if we want to modify this particular value and not the one that is copied into the function, we can modify two things. All right, so the first one is to change our function definition or our function signature to accept a pointer. Okay, so let me comment this. I don't like seeing those wiggly lines, it just distracts me. So set a new country value. All right, so spell country correctly. Yeah, so it goes away now. So yeah, so we're going to change the function signature to accept a pointer instead of a value. And how do we do that? We attach the star, just one star. So we attach the star key behind the type, the data type that we're expecting, and then we change the parameter or the argument that was passed into the function, and we add the ampersand. Okay, if you remember in a guessing game, for those that saw it, I talked about the ampersand, how it's a way of fetching the address of a variable. So what will happen here? The Go compiler will fetch the address of this Nigeria variable and then pass into this function. Okay, so we can go ahead and remove this print statement here, and when we try running this code again, we should see that our information is updated. So pointer is an address. So what will happen is this function will now locates the address where this thing is saved, and then updates the value with the new value and puts it back there. So when we call our print ln on line 33, it still goes to the same memory space where Nigeria was saved and fetches the same data and tries to print it again. So if we are passing a pointer to a particular variable, it means we're working with the same variable all across our program. It's just the same thing saved on the same spot, so anybody can go to where it is saved and change it. That is basically what we are doing here. We are going to where Nigeria is saved and we are trying to change it to a new value. So there are so many other applications of pointers. All right, so we can do let's say if we want to define an integer variable, so we can call that n and say int. So if we want to get the pointer instead of the value itself, we do the same thing. We attach the star behind this, and this should be an pointer, an integer pointer. That's what we expect here. All right, so we can go ahead and update the information there. We can do something like n equals to 40. Okay, so and also print that too. And yeah, now because this is not an ordinary variable, this is now a pointer, so we need to tell the Go compiler that it has to first of all dereference the pointer that was declared up here. All right, and so the reference means that it has to first of all go to the memory space where this n was saved, and then put the value 40 to our variable. So to do that, we put the star behind the n, and that should work too. So we can go ahead and run this, and there is a problem here. Invalid memory address for nil. Oh yeah, so this is a nil pointer, and so it's not allowed. So we can let's assign it to a value to it, and see what happens. And hold on. All right, so it's not possible to actually assign a value directly to our integer pointer. So the easiest way to solve this would be to use the new function, which basically creates a pointer of an integer pointer value that we can now easily assign the value to. So can go ahead and do that, and then do something like call that 40, and we can now use the reference to get that to work. So yeah, as you can see, this returns the address. This is actually real memory address. As you can see, we have this is actually hexadecimal. Yeah, so yeah, that's it. So I think if you want to print the value, we can I think we should use another star, right? Is that? Yeah, I think so. So yeah, that will also dereference it for us to print. So because this remains an int pointer, yeah, or pointer int. Sorry. So yeah, so that's the way to go about using something like this. But the good thing with using a pointer as our int value is that we can pass this integer to different functions, and every function that it tries to update it can update it. So we can even assign a new value to it here. I can call this 50, make sure we add this, and depending on what runs first, yeah, that shouldn't be a problem. So we can call this down here, say set country, and we'll need to pass in a pointer to this, to the first value. So we can do pointer COVID starts, and then value. So this is just to stop this function from panicking. To save that and execute it, you can see that the value changes. So as we try to update it here, it still runs, and we didn't need to define it. So even if it's outside of this package, this value can be updated by anybody because they now know where it's located. They can locate it and just update it. All right, hopefully that makes some sense. And yeah, I think that's what pointers are, and we'll go on and use them in functions and methods definitions, and hopefully it will get even more clearer there. Okay, so that's that on pointers. And so the next thing would be to talk about we're going to talk about let me check the topics. Yeah, so we'll talk about consts and the iota, and after that we'll quickly talk about functions and methods. Okay, so let's get down to business. All right, type declarations. So type declaration is where we declare a new name type. Okay, so by that I mean we're basically creating our own type. So maybe there is a type that is specific to the program you're writing at that moment. So let's say, for example, we are writing an accounting software, and we need a data type to represent an employee's account number. So this data type could contain the name of the employee ID, the salary, how long they've been with the company, all that information. We cannot represent them using the regular ints and floats and integers. That's going to be a very, very difficult thing to do. So what if we can create our own types and add that information into our custom type. Okay, so as you would already know, we've already started talking about the type declaration when we treated structs. Okay, so structs are one way to represent complex data types, as we have seen, but that's not the only way to create types in Go. Okay, so yeah, now we've talked about pointers, and I've shown you what pointers are, how we can use them, and as you can see here that we made use of the new function to initialize our pointer. And yeah, so that's that for that. And moving on, we can go ahead and talk about functions and methods. Okay, so let's quickly open our main.go file and start by that. So let's see, I'm just defining the function down here. So to define a new function in Go, we can do the func keyword, which you've already seen. We've been doing a lot of function main, and this is just one function, special function in the context of Go. Okay, so but as you have already seen throughout this course, we've been defining some tiny functions that we use to get some things to work. So what I've shown you is literally what functions are used for. So they are used to combine a series of statements. Okay, so you want to do a couple of things, you want to operate on a specific kind of data, you want a group of statements that will operate on that data and then produce something different, or maybe something that you want to change the state of an information to yield what you desire at that moment. So a function could actually do it. Okay, so now let's say we want to define a function, call that function add. All right, and what function add does is it adds two numbers. They are both ints, so we can define it like this, and then what comes here is what we call the return type. So these two variables, or these two numbers, a and b, are called parameters. All right, so we can either define them like this: a is a variable of type int, and b is another variable of type int. But since they are the same types, we can get rid of the first int, and we're basically saying that a is equally of int type. Okay, so we can now provide what is called the return type. In our case, we want to return an integer type, so we just go ahead and type that. So this is what we call a function signature. Okay, so this is the signature of this function. It expects two parameters and returns an int type value. Okay, so we'll put the curly brace, and this is called our function block. So whatever that we define within this function or any new variable, it remains local to this particular function. So this is the scope. In the previous videos, I talked about scope where I mentioned the package level variables and local variables. So this is a function scope. So everything that we write or create, any new variable that is created in this function remains in this function. It cannot be accessed outside of the function. Okay, so this is the body of the function. Yeah, so this is where the whatever you want to now aggregate can now be added. Okay, so functions are first class types in Go, which means that they are treated as a type. All right, and yeah, you see them everywhere you go. They provide us a means to wrap a sequence of statements and expressions into a single unit. Yeah, so long story short, like I've already mentioned, they make it they give you the ability to combine a series of operations and put it in one function. All right, so let's look at some examples. So let me start with let's say we want to add two variables. So have a variable a, all right, and b. Sorry, so let's assume that this a is 20, and then I'll have b, and b is 30. Okay, so and we want to add the two of them, right? We can easily go ahead and say r for result is a plus b. Okay, and this should return give us the answer and print and r. All right, so now this should work. Okay, let's run it to make sure that it's working. Yeah, that works fine. 50. So now let's assume that we have two new variables that we want to add. So let's say we have c, called c, minus 5. Where is it? Yeah, minus 5, and d, call it 15. Oh, 15. Yes. And now we can also have another result. Can now reassign our result value, and we'll have to do something like c plus d, right? That's our result. And we can also go ahead and print fmt, print line, print r again, and so on. So we can just be doing this over and over again. And there's something I want you to notice on line 10 and 15. As you can see, we are repeating the same operation and we are having to write it twice. All right, so what if we can remove all of this work that we are having to do before, you know, specifically these lines, this and this? So what if we can actually, because they are doing the same thing wherever you go, everywhere you go in the universe, the laws of physics, as far as we know, remains the same. So 1 plus 1 will always be 2, 20 plus 30 will always be 50. So why there is no need to actually be repeating ourselves over and over again. So we can go ahead and abstract this operation. So what I mean by abstracting is by taking it away and putting it inside another function. Okay, so we want to add just two variables, so we can define a function signature to take two variables, and we expect that the addition of int and int should be an int. So that's why our return type becomes an int. That is what we want. So we define a function that meets exactly what we want. Okay, so the function signature matches what we desire our program to do. So we can now go ahead and return. So the return keyword returns the answer to, or it returns any value that comes to the right of it. All right, and we're having a red squiggly line here. Oh, this has been declared somewhere else. Okay, let me just change this to ints. All right, so let's just say add ints. Okay, so now what can we do? So we can go ahead and get rid of all this and then just use the function that we just created. So add ints, and then we'll call this 20 and 30. Okay, so do the same here. R equals to an int. So this should be -5 and 15, and just to make this look better, can change this to print. By the way, if you want to select multiple texts that are the same, you can just use the Control D. So if you, for example, if you want to select all the printfs on this page, put your cursor on the text and then hit Control D twice, and as how many times you want to select them. Okay, if you want to remove, just press the escape key and that will remove it. So we want to modify all the printfs, so just going to go ahead and then say so just going to use %s here and add a new line. Okay, so you can say yeah, I'm gonna say 20 plus 30 equals to, yeah, same thing goes here. Let's say -5 plus 15. That's this. Run this code again, and as you can see, oh, what? This doesn't look right. Print f. Oh yeah, this is a very basic mistake. So we're expecting a digit, not a string. So change that to D, and everything should work. Yeah, so that is looking good. So yeah, that is one use of functions, and can also declare types that are, that's a function type. So we can say type add. Let's say add I is of type func, and then b int, or don't need to add that one, just say int and return an int. So this is actually a type. Okay, so it's exported, that's why we're getting this. So we can add a method here, say as integers. Okay, so yeah, so we can now come in here and go ahead and define var, call this adder. So just adder, yeah, it's of type add int, add I. Okay, so this is a valid type, so we can now assign this to a function. So this is what it means that they are treated as first class types in Go. So you can pass them as parameters, you can define variables and assign them to functions, just a bunch of regular things that we can do. So we can just call this x and y and int, and yeah, returns an int. So we can just go ahead and return x plus y. Okay, so yeah, declared but not used, so we can now actually go ahead and use it by saying okay, let's use printf, and we're going to say let's say 500 plus 400 equals to %d. Add the new line, then you can go ahead and say adder pass 500 and 400. Okay, so if we run this, and everything works as expected. So yeah, this might be a little bit confusing to you, and I deliberately added this here so that just have this in mind. You won't see this a lot, okay, but just in case if you come across it, so you won't be surprised. All right, this actually exists in Go, so we can actually define functions and pass them all around like this. Okay, now let's talk about that is about functions, by the way, and as time goes on, we will see some much more complex things that we can do with functions. All right, so now let's talk about consts and the iota. So constants, like the name sounds, are constants. All right, so there are those things that we know what they are at the beginning of the program, so they are not going to vary like a variable. They are always the same. Okay, so an example of a constant could be pi. So we know that pi is 3.14. So there we go, define that like that. Okay, so no, yeah, so yeah, that's it. We use the const keyword to define it, and that is it. So pi is to be exported, that's why it's complaining. And so I'll just go ahead and that's, yeah, the pi, okay. So this is what it is. So we can have an int const type, can also have a floats, and yeah, I think strings too. So but it's mostly only the basic data types that can be used as constants. I don't think we can define structs as constants. No, that will be what you can find out on your own. But for now, just know that constants are those declarations or those variables. They are not variables per se, but they are those values that is expected to remain the same from the start of the program to the end of it. Okay, so iota, on the other hand, is Go doesn't have the concept of enums. All right, and so the constants and iota are a way to actually represent enums in Go. If you don't know what enums are, don't worry. Okay, so let's say that we have what we call gender. Okay, so we can go ahead and define a type. Okay, so call it gender, and we want to represent it with ints. Okay, so we want to have we have different genders, of course. We have the male, we have the female, and yeah, those other new genders that we'll have these days. So we can go ahead and yeah, I think we have non-binary and all that stuff, but let's assume that we'll just have two genders now, male and female. Okay, and maybe other. All right, so to do that, we can go ahead and say male. This is the constant. So the first one is the variable name. All right, we'll call it male. Now we'll give it a type of gender. Okay, so notice this brackets that you're seeing here. So this is just like you can see in the imports. All right, so if you want to actually define multiple imports, use the brackets. It works for const too, even for variables. So if you want to define multiple variables in the package level, you can actually do something like this. You can say var n ints, have var f float 64 or 32, and also val t bool. This is valid, just defines multiple variables instead of writing var. This just covers the whole vars for you. Okay, so now yeah, so we now to assign this value to this, so we can maybe use int1 to represent it. All right, yeah, so let's go ahead and try and print this out. So I'm going to go ahead and comment all these things out here. All right, so let's go ahead and say fmt.println, or we can just maybe actually use real variables to define it. So we can say Tim is of type. Okay, let's just use var. Say var Tim is gender. Okay, or yeah, let's just do this. So Tim is of type male. All right, so we can let's first of all go ahead and print this out and see what we get. And what? Okay, yeah, it shows up now, and so go ahead and print that out on the console. And I think this should be let's see, 0. So that is the 0 value. So gender is an int, so this is basically an int. All right, So but if we said something like let's do something. So if we did fmt dot println and we go ahead and say that we know that team is 0, right? Team is equals to 0. Let's see, it says true. All right, so that is fine. Okay, but let's try something else and see. Let's say var n is of type int. All right, so if we say var n is equals to type t, as you can see, there is already a problem: mismatched type. All right, so whereas a gender is still an int, so if we create a variable that is directly an int, it's going to complain because they are not of the same type. This is a gender type, not an int. I don't know, this might be a bit confusing because if you look, you see that the gender is actually of type int, like we define up here. But now we are trying to compare it to another int, team, to another int, and it's saying that no, that this is a mishmash type, so they are not the same. All right, so this is how where this thing comes in handy, where you can really have use enums to define something like this, and it really works. All right, so yeah, that is consts and type declaration. Type declaration with consts and ints. So now this is a let's now use iota to actually extend this. So let's say we have a female here, and the female is a gender 2, and yeah, we can see that it's number 2, right? And then have other, it's also a gender, and you can see it's number 3. All right, so this works well, and we can actually present this with these numbers, and everything looks cool. If we actually try and print this, you can see that it all would work well. So we can actually assign team to let's say we can assign team to be a female. Sorry, and yeah, it should actually work. Yeah, see, works. Okay, so now this is nice, and sometimes you might find out that you would want to have as many types here as possible. Maybe you want a very simple way to represent, let's say you are writing an HTML parser and you want a very simple way to represent a list of your types, and of course you couldn't want to be defining it one by one. If you want the h1 tag, you use a number to represent it, you hate the p tag, there are just a lot. Okay, so this is where iota comes into play. All right, so we can actually use the iota keyword to make it easy for us to assign all these things. So when you use iota, okay, so the iota keyword just goes ahead and assigns this value for us in an incremental manner. All right, so let's run this code again and print this out. As you can see, this is now 0. Okay, sorry, 1. So the first one, which is a male, if I assign that to team and print it, becomes 0. If we try to do for other, as you can see, yeah, 2. So incrementally, if we go ahead and add new things here, new stuff, say new gender, so this gender type gets assigned to all of them one by one, and then the value is incremented by 1 each time there is a new one that gets added. So if we assign team to new gender and try to print that out to the console, you should see that it's 4. Okay, so this might not be the most useful way to actually make use of this. There are actually really useful ways where this iota can really come in handy, like I said, with the HTML parser and some other aspects of your programs might require a feature that's like this that can really make sense to you. So the good thing about this is we can even have multiple types, and this could be a gender type, and if we compared both of them, we shall see that returns true because they are of the same type and of the same value. Okay, so yeah, now that's it about on constants and iota keyword. And if you have any questions, please reach out to me. I'll do my best to answer them. Right, finally, let's talk about methods. Okay, so if you have any experience with object-oriented programming languages, you probably could have come across classes and methods and all that stuff. So methods are functions that are attached to a struct. Okay, so let's go ahead and define a new struct here. Okay, so let's just say that we define a new type, not just for structs, sorry. So for example, we can actually attach this int, this gender type with a type. So actually let's try that. So let's attach it. So let's get a function called toString. All right, so what toString will do is to print the string value of the gender. Okay, so to attach this function to our gender type, this is how we do it. So we can call it G for gender, and then you can use the gender type here. So this function attaches this particular this statement attaches the toString keyword to all of our genders. All right, so let's quickly write a quick function that would make that work. So I'm going to quickly pause this video and type it out so it doesn't add more unnecessary typing time. Okay, so I took the opportunity to also clean up this function just to make sure that things are a bit cleaner to look at. So yeah, so this is a function, it's a string function. It right, so I stopped the video again to get all the program fleshed out. So I'll now take the time to walk you through everything that is happening. And yeah, so what I did here was we attached the toString method. So this is a method, all right? So a method is a function attached to structures. So not just structures actually, so but data types to a type. Let's just say type. All right. Okay. So yeah, that's what methods are. Okay. So in our case, we've attached the toString to the gender type, and this is how you do it by declaring these statements in your function. And so you can see the difference between our int function. So you can see this function is not attached to any type, it's a standalone type, okay, as opposed to this toString function that is attached to the gender type. Okay, so what we are basically doing is we are using the switch statement to check for the case. So when the gender is a male type, so remember we declare these types up here, the male, female, or then the new gender. Okay, so if it's a male, return string male. If it's a female, return the female, and so on. If we don't know the gender, just go ahead and return unknown gender. Okay, so by the way, let me quickly add declaration for that. So let's call it UG. This could be a gender type, and let me think if I assign this to a 4. Yeah, it's going to complain because it really does not know what it is. So yeah, so you see the advantage of using a typed language. If this was a dynamic language, you can easily assign this number to it, and nobody will complain. It will just crash when the code is running. So yeah, let's remove it. It's not going to work because you've seen the red squiggly line. So to prove it to you, let me run this code. As you can see, it's going to crash. Okay, it's actually, oh, hold on. Okay, so let's see UG, and if we use the UG again, it seems to not complain. Awesome. Okay, so yeah, that wasn't, but what I'm saying still applies. Having statically typed languages does detect some type anomalies for you, all right? But because a gender is an int type, this just makes it work. Okay. Assuming that if this was a new gender, I think it's going to complain because okay, it's actually not a type, it's a value, so that's not the reason. Okay, but yeah, you get the point. All right, so I'm going to go ahead and run this code. If I run it now, should see. All right, I missed something. Let's add new line, so this is actually printed out. Good screen. So print that again. As you can see, team is a male gender, Jane female, they, and so on, and UG, yes, our default just runs. Okay, so yeah, this is methods and iota, const, and I think that is that on type declaration. So thank you for joining, for seeing this video. If you have any question, please drop it to send me a message on Twitter, or wherever you can contact me. I'll drop all my information in this video description. And yeah, so all these videos might seem overwhelming, but give it time, ask questions, and practice with them, and you will get used to it eventually. All right, happy coding.